see about congruence modulo. That is what we are going to work out in exercise 2.3. So what is congruence modulo? Two integers a and b are said to be congruent by modulo n if they differ by an integer multiple of n. So we write a is congruent to b modulo of n, or we can say that a is a multiple of some number of n. So a is some multiple of this some number n, and when you divide it's a multiple, we get the remainder b. So we can also say that a minus b is equal to some multiple of n. So b here is the remainder. We can also say a minus b is some multiple of n. So if we take the number 56, when you are dividing it by 3, let's see what will be the remainder. 3 ones are 3, 8s are 24, and your remainder is 2. So we can write this as 56 is congruent to 2 mod 3. That means 56 minus 2 is equal to some multiple of 3. So how can I write 56 minus 2 is 54, which is nothing but 2 into 3 into 18. So this is what we are going to do in this congruent modulo. So let's move on to the exercise. So find the least positive value of x such that, so here it is very much given here least positive value, which means that there are many positive values, but in that I want the least, which is the first starting number of x. Now here they are given 71 is congruent to x mod 8. So as I have to explain to you, so I am bringing this remainder x to the other side. So I write 71 minus x is some multiple of 8. So how do I find it? We can divide 71 by 8. 8 is 64. The remainder is 7. So 71 minus 7 is some multiple because you have two terms, and mod 4 will write some multiple of 4n. Now in the next step, 89 minus 6, so minus we are multiplying inside, minus 3 is equal to 4n. 89 minus 3 is 86, minus x is equal to some multiple of 4. So let's divide and see. 86 by 4. 4 2s are 8. And the next number 6. 4 1s are 4. Your remainder is 2. When 86 minus 2 is going to be a multiple of 4. So in the place of x I have written 2. So that is my least positive value. Same way, in the fourth subdivision we have 96 is congruent to x by 7 mod 5. So in the next step I bring 96, the remainder x by 7 to the other side, it becomes minus x by 7 and it is a multiple of 5. I take the LCM, 63 minus x by 7 is some multiple of 5. I am moving the 7 to the other side. 672 minus x is equal to 35n. Now we have to find what is the least positive value. For that, let us divide 672 by 35. 35 2 3, so we have 9. The remainder is 7. So 672 minus 7 is some multiple of 35. So my least positive value here is 7. Now in the fifth subdivision, we have 5x is congruent to 4 mod 6. So in the next step, we write it as 5x minus 4 is some multiple of 6. So we already have x is being some multiple of 5. So for that, I start taking the values of x to be from 1 because they have given least positive value. So from 1, 2, 3 and so on. And if you see here, when I substitute here 5, that is when x is 1, 5 into 1 minus 4, it will be 1. 5 ones are 5 minus 4, 1, which cannot be a multiple of 6. So next I take x to be 2. So when I take x to be 2, 5 into 2 is 10, minus 4 will be 6. So 6 is a multiple of 6. 6 ones are 6. Now when I take x is equal to 3, 5 3s are 15. 15 minus 4 will be 11. So I cannot just like that take on, but I can take like this. It is all a multiples of 6. So you can know that multiples of 6 differ by one number by the other by 6. Like 6 ones are 6 and 6 twos are 12, 6 threes are 18, 6 fours are 24. So here you can very well see the difference is plus 6. So when I take my x value to be 2, the next number surely is going to be x is equal to 8. So when x is 8, you can see 5 into 8 is 40. 40 minus 4 is 36. So 6, 36 are all the numbers which are all a multiples of 6. So the x value over here will be from 2, 8, 14, 20 and it goes up. But what is the question given? Least positive value. So which is the least value? already we have taken x. So we write y modulo 17. So what is the number y? So we have to find the value of y. Now let's see the given statement. X is congruent to 13 modulo 17. So which means that x minus 13 is some multiple of 17. Now here also again, if you see x is unknown, so how do we find it out? We know that 17 multiples is 17 ones are 17. So here 17 cannot be, if you take 1, 2, 3 and all, you cannot start. So the starting number for x is going to be 30 and x is 30. 17 table, 17 ones are 17, 17 twos are 34, 17 threes are is 51. So it goes on. So the starting number itself is 30. We have 17 here and we have 13 here. So when I take 1, 2, 3 and all, it is very, it will come in the minus number, negative number. So here I am taking x to be as 30. So when you take 30, value of x as 30, you can find is equal to 17. 30 minus 17 is 17 is nothing but 17 ones are 17. So I am taking here x value as 30. Now this x value we are going to substitute in what is the statement that we have to find. So substituting x is equal to 30, 70 into 30 minus 3 is congruent to y modulo 17. So 70 minus 7 into 30 is 210 minus 3, and I am going to bring this y to the other side. Minus y is some multiple of 17. So 210 minus 3 is 207 minus y is some multiple of 17. Now let us divide 207 by 17. 17 ones are 17. Remaining 3 bringing down that 7. 17 twos are 34 and you have your remainder 3. So we can write 207 minus 3 is some multiple of 17. So in the place of y, we have found the value of y to be 3, and that is my answer. The third sum, solve 5x is congruent to 4 mod 6. Now here in this sum they have asked to find the value of x, and that too not a specific value. When you find solve, usually we find only one specific value, but in congruence modulo we get many values when we solve the value for x or unknown variables. But in the previous first sum we had specifically mentioned least positive value. Here there is nothing mentioned like that, so it is given as solve. Now let us start solving it. So next step will be 5x minus 4 is some multiple of 6. So here also x is already a multiple of 5. So we don't know what multiple, so we start assuming the x value to be from 1. As I told you earlier, if you take 1 when x is 1, 5 into 1 minus 4. 5 ones are 5 minus 4 will be 1, which cannot be a multiple of 6. 6 multiples you know, 6, 12, 18, 24, 30, and it goes on. So each number of the tables of 6 will differ by a number 6. They are getting added. So when I take 1, it is not a multiple of 6. When x is equal to 2, 5 into 2 minus 36. Yes, of course, 36 is divisible by 6. It's a multiple of 6. The same way, the next number would be, when you add 6 to it, it is 14. 5 into 14 minus 4. So 14 5s are is 60. 60 minus 4 is 56. 5 into 14 is 70, and 70 minus 4 is 66. So here we can see that all the answers are multiples of 6. When the x values also we can find that x values start from 2, 8, 14, 20 and it goes on. So these are the possible values of x. The fourth sum is 3x minus 2 is congruent to 0 mod of 11. So we have to find for what values of x do we have this remainder 0. So already we have 0 there. We can write it as 3x minus 2 is some multiple of 11. So 11 multiples you know very well. 11 ones are 11, 11 twos are 22, 11 threes are 33, 11 fours are 44. So the difference between each now multiples are 11. So 11 gets added to the each digits. So here for what values? So I'll take when x is when x is 1, 2, 3, 5, 4, 5, 6, 7, 8, 9 and so on. So of course within these numbers somewhere it has to be started up because then only it will be divisible by 11. Once we know the first value which is going to be divisible by 11, then the next number can be found out very easily by adding 11 to it. So when x is 1, so it is 3 into 1 minus 2, 3 ones are 3, minus 2 is 1. So it is not be a 11 multiple. The same way when I take x is 2, 6 minus 2, 4, not possible. When x is 3, 9 minus 2, 7, this is also not possible. When x is 4, 3 fours are 12, minus 2 is 10. We cannot take. When x is 5, 15, 3 5s are 15, minus 2, 13 is not a multiple. Again, the x is 3, 3 6 are 18, minus 2 is 16, it's not a multiple. When x is 7, 3 7s are 21, 21 minus 2 is 19. Is also not a multiple of 11. Then next, when x is 8, 3 4 3 8s are 24, minus 2 is 22. So now we have finally found out the goes on. So these are the possible values that we have for the sum. The fifth sum, what is the time? 100 hours after 7 a.m. 100 hours after. So here we can very well see that that 100 hours, the word 100 hours, if you take for calculation, the one day we will have how many hours? 24 hours. So to calculate for 100 hours, we are going to keep on adding this 24 plus 24 plus 24, and it is going to be keep on adding. So here you can find the repeated number is 24. So the repetition which is happening here, that number is going to be taken as modulo. So the modulo, first we will write that is 24. So we are going to write 100 is congruent to 7. So we are going to write 100 is congruent to some number modulo 24, where you can write in the next step 100 minus 6 is some multiple of 24. So let's divide 100 by 24. 24 fours are 96 and the remainder is 4. So 100 minus 4 is a multiple of 24. So here in the place of x we have 4. Now we have found what is the value of x. But what is the question asked? 100 hours after 7 a.m. So 100 hours after 7 a.m. After, so when they have mentioned here after, it means it's going to extend. So 7 plus, here we have 4. So we are going to add that value of x and it is 11. So 7 plus 4 is 11 and we have a.m. because since 11 only have 4 hours after 7 o'clock in the morning, so it is 11 a.m. What is the time? 15 hours before 11 p.m. So in the sixth term we have 15 hours mentioned. So 15 hours, of course, it is going to be within a day. So in a day, how many hours you have? So one day you have 24 hours. But within a day, how do you calculate this with? One day. So one day, this 24 hours is nothing but 12 in the AM and 12 in the PM. So here you can find, here the repeated value is 12. So here we will have the modulo to be as 12. So 15 hours before 11 p.m. before. So I take my 15 to be is congruent to some number modulo 12, where I can write this as 15 minus x is some multiple of 12. So when I divide 15 by 12, 12 ones are 12 and my remainder is 3. So 15 minus 3 is a multiple of 12. So 15 minus 3 is 12, 12 ones are 12. Here my x value is 3. Now what are they asked? They have asked 15 hours before 11 p.m. So 15 hours before 11 p.m. So 11 minus 3, it's 8 a.m. Now why do we write here a.m. is that this is 15 hours. So more than 12 hours from p.m. it's going going to be your AM. So that is why we found it as we are writing the answer as in AM. The seventh sum. Today is Tuesday. My uncle will come after 45 days. So after 45 days. So here we have days being mentioned. We know in days. So 7 days makes a week. So in 45 days we know there are many weeks. So here many weeks will be repeated. So 45 days. We will be adding weeks after weeks after weeks. So here the repeated value is 7. So our modulo is going to be 7 over here for this sum. In which day my uncle will be coming? So if I calculate from now, after 45 days, so today is Tuesday. On this day, after 45 days, on which day will my uncle come? So here 45 is my value, that is going to be congruent to some value modulo 7, which means 45 minus x is some multiple of 7. So 45 when I divide it by 7, 7 6 are 42, my remainder is 3. So 45 minus 3 is some multiple of 7. So the value of x over here is 3. Now what have they asked? 45 days after. So after Tuesday. So 45 days from Tuesday. So from Tuesday you are going to add to 3 days. Why adding? Because you have after. So when you have after, it is going to be third day will be your Friday. So the answer will be uncle will come on Friday. Now we have the 8th sum. Prove that 2 power n plus 6 into 9 power n is always divisible by 7 for any positive integer n. So for proving this statement, we are going to use other statements of congruence modulo. If A is congruent to B mod m, then we can write AC is also congruent to BC mod m. Then A plus or minus C is congruent to B plus or minus C mod m for any integer C. So we are going to take this statement and prove this. So we have in the question 2 power n plus 6 into 9 power n. So we are going to write this as 2 power n plus, here I am going to expand the 6 as 7 minus 1 into 9 power n. Next step, 2 power n plus, I am going to multiply all this with 9 power n. So 7 into 9 power n minus 9 power n. Now I write two statements. 2 is congruent to 2 mod 7, and in the same way 9 is congruent to 2 mod 7, which means that 2, when you move this 2 to the other side, it becomes 0, and it is also a multiple of 7. When you have 7 zeros are 0. The same way here 9 minus 2, 7, and that is also the multiple of 7. 7 ones are 7, or we power n minus 2 power n mod 7. So 2 power n minus 9 power n is congruent to 0 mod 7. So this I am going to substitute in 1. This is my first equation. So from 1, so from the first equation you can write, that is we have written already 2 power n plus 6 into 9 power n is equal to 7 into 9 power n, and we have written this together 2 power n minus 9 power n, where we have found out this 2 power n minus 9 power n as is congruent to 0 mod 7, and already we have proved that the remaining number is also a multiple of 7. So finally I can write 2 power n plus 6 into 9 power n is congruent to 0 mod 7, which means that this value is a multiple or a divisible by 7. When I say divisible, your remainder is going to be 0. So that is what we have proved here. When 2 power 81 is divided by 17, so 2 power 81 is congruent to x mod 17. So this is what has been given as statement, and we have to find the remainder. So 2 power 81. So we all know 2 is congruent to 2 mod 17. When I am raising this to the power 4, on both sides 2 power 4 is congruent to 2 power 4 mod 17. We can even write it as 2 power 4 is congruent to 16 mod 17. Now we have raised this to the power 4, and we are writing it as, I am keeping my left hand side as such. So 2 power 4 is congruent to, now 2 power 4 is nothing but 16 modulus 17. Now how can this statement be? So here also I have written 2 is congruent to 2 modulus 17, and 2 power 4 is congruent to 16 modulus 17. So when I divide here 2 by 17, since this is a smaller number, my remainder is always going to be as such 2. The same way, here 16 also is a smaller number, and I can just leave it off. It's a smaller number than 17, I can leave it off as such. But now here we are going to do a small change, that is, if I divide 16 by 17, say 17, when I subtract, my answer would be minus 1, and this is my remainder. So 2 power 4 is congruent to minus 1 mod 17. When 2 power 4 is divided by 17, I get the remainder minus 1. So now in the next step, again I am going to raise both the sides to the power of 20. Raising to power 20. So when I raise both the sides to the power 20, 2 power 40, the whole power 20 is congruent to minus 1 the power of 20 mod 17. So any negative number to the power of even number, your answer would be positive, and that to minus 1, how many times you multiply, you will get modulo 17. Now I am going to multiply this by 2 on both sides. Multiply both sides by 2. So I will get 2 power 80 into 2 is congruent to 1 into 2 is 2 modulo 17. So 2 power 8 into 2 power 1. So in multiplications the powers get added. So you get the answer as 2 power 81 is congruent to 2 modulo 17. So finally I have proved what they have asked. Now the last sum of the exercise, the duration of flight travel from Chennai to London. So a person traveling from Chennai to London. So how long is the flight travel? Through British Airways is approximately 11 hours. So 11 hours it takes for a person to travel from Chennai to London. The airplane begins its journey on Sunday 23:30. So here flight is leaving on Sunday at 23 hours and 13 minutes. If the time at Chennai is 4.5 hours ahead means in front, after. So how we did for the previous sum, the time calculation. So it is after. So ahead to that of London's time. So if it is 3 o'clock there in the afternoon, it's going to be 4.5 hours. So it is going to be 7:30 in the evening over here for us. So it is 4.5 hours ahead. So 3 o'clock afternoon for them, 7:30 for us in the night. So they are saying they are 4.5 hours. So Chennai is 4.5 hours ahead. So 4.5 hours. Then find the time at London. When will the flight land at London's airport? So find the time at London when the flight lands at London airport. It's very simple. The flight is being departing from Chennai to London and the journey is 11 hours. The flight is leaving at 23 hours 30 minutes on Sunday. If it goes for 11 hours, at what time will it reach London? And on which day also? So 11 hours of journey, you see it is going to be 34 hours 30 minutes, the time we are seeing it. And what is the time there in London when it is 23 hours 30 minutes? So it is going to be back. So the time now at London will be at the same time will be 19 hours. When it is 23 hours 30 minutes in Chennai, the same time it is going to be 19 hours in London. It is going to be 19 hours at the same time when 23 hours 30 minutes is going to be in Chennai. Now after 11 hours, if you see, it's 34 hours 30 minutes. So the total timing, if you see, calculating with the time at Chennai, it is 34 hours 30 minutes. And if you subtract the time difference, it will be 30 hours. So 30 hours after this we are going to find out, and you can find the time calculation over here is 24 hours. So the modulo over here is 24 Then 30 minus x is some multiple of 24. So when I divide 30 by 24, ones are 24, your remainder is 6. So 30 minus 6 is some multiple of 24. Here the value of x is 6. So what is that x value? That is 6, and that is nothing but the 6 hours. So here we have found the value of x to be 6 hours, and now we have to find the time. So now the flight will land at London